Third sum, first subdivision. Once again we get a modulus sum. Whenever the modulus sum comes, you put such type. Here x is equal to 0. X is equal to 0. Okay. This one we can take as x is equal to 0 minus 0 plus. This is left hand limit. This is right hand limit. The nearest value, we need to apply the nearest value. The nearest value of 0 point is nothing but minus 0.1. Sir, whether I take a minus 1 value, whether I can take a minus 2 value, you should not take minus 1, minus 2. Take the nearest value. They can be minus 0.1. Otherwise, minus 0.01 also, no problem. Nearest value, very, very nearest value. The same here also, the nearest value is nothing but 0.1 or 0.01. So, using this only we need to find. Okay, because once the modulus comes, we need to take the value. Then only we know whether it's a plus value or minus value. You should be very, very careful in that. So, first apply the left hand limit. What is the left hand value? F dash of, what is given here? 0. So, 0 minus left hand. If it is for right hand limit, f dash of 0 plus is equal to limit x tends to 0 minus f of x minus f of 0 divided by x minus 0, the same formula here, but only limit changes. F of x, limit x tends to 0 plus f of x minus f of 0 divided by x minus 0, that's all. Now apply the value. So limit x tends to 0 minus f of x, 0 minus nothing, listen carefully, 0 minus, this is a left hand limit, you need to move to a left hand. What is the answer? Minus 0.1. Write x as it is, write x as it is. If I go in, this value is going to be negative only because x is nothing but minus 0.1. So it's going to be negative only, so write negative. The value is going to be negative because x value is nothing but minus 0.1. We are getting minus value, so minus 0.1. So I write minus as it is, minus. In place of x, apply this f of x value is nothing but x into minus x. Apply in place of x, apply 0, f of 0. F of 0 is 0 into 0 is going to be 0 divided by x minus 0 is nothing but x. Therefore, limit this x we can cancel. Therefore, limit x tends to 0 minus x. Apply in place of x, apply listen very carefully. In place of x, apply the value 0. So, answer is going to be 0. In place of x, apply the value 0. So, answer is going to be 0. Left hand is over. Next, right hand. The same limit x tends to 0 plus. X tends to 0 plus. See, check it carefully. What is the answer is going to become? F of x. 0 plus means first write x as it is. Modulus only we need to find. 0 plus. I am applying x is equal to 0.1. X apply as it is. If x value is 0.1, 0.1 is a positive value. So positive, x is positive. So write x as it is. In place of x, apply 0. 0 into 0 is nothing but 0. X minus 0 is nothing but x. So limit x tends to 0 plus, x and x we cancel, only x. In place of x, apply 0. Answer is going to be 0. Both are same. Therefore, f dash of 0 minus is equal to f dash of 0 plus. Therefore, f dash of 0 exists. This is the first subdivision. See, now once again the modulus comes. If modulus comes, what do you want to do? We need to put 1 like this. 1. If it's going to be 1 minus, it is going to be 1 minus and 1 plus. Left hand, right hand. At x is equal to 1, we need to show. If x is equal to 1, I can put before that value. 1 before value is nothing but 0.9. Plus 0.9 only. 1 after value is nothing but plus 1.1. For left hand, I am going to apply this value. For right hand, I am going to apply this value. That's all. So now apply here. What first right? Apply the formula. F dash of 1 minus is equal to limit x tends to 1 minus f of x minus f of 1 divided by x minus 1. Next, limit f dash of 1 plus is equal to limit x tends to 1 plus f of x minus f of 1 divided by x minus 1. Now apply the value and find whether the modulus value is going to be plus or minus. If I am going to apply left hand limit, what is the left hand here? 0.9. 0.9 minus 1. Whatever it may be, 0.9 the whole square nothing but 0.81. 0.81 minus 1. The 1 is the biggest value. It's going to be minus value only. It's going to be minus value. Modulus is going to be minus of First I need to apply limit. Limit x tends to 1 minus, this is going to be minus value only, because if I going to apply 9, 0.9 the whole square is nothing but 0.81. 0.81 minus 1, that minus 1 is the biggest value compared to 0.81, minus no, so it's going to be negative value only. So minus of x square minus 1 minus, in place of x apply 1, 1 minus 1 is 0, divided by x minus 1. So limit x tends to 1 minus x square minus 1 square. X square minus 1 square, we can write 1 square, no problem. Nothing but x plus 1, x minus 1 divided by x minus 1. Both will be cancelled. So limit x tends to 1 minus, what is the remaining here? Minus of x plus 1. Minus of x plus 1. Apply the value of 1. 1 plus 1, 2. So answer is going to be minus 2. 1 plus 1 is nothing but 2, nothing but minus 2. We are getting the answer as minus 2. Okay, apply value 1 only now, you should not apply minus 1. The value is x value is 1 only. 1 plus 1, 2, minus 2. Once we apply, we should not put limit once again here. That's all, over. The same here also. Limit x tends to 1 plus f of x. Apply 1.1. 1.1 the whole square minus 1. 1.1 is the biggest value. So you are going to positive only. So write x square minus 1 minus, in place of x apply 1, 1 minus 1 is 0, divided by x minus 1. Limit x tends to 1 plus x square minus 1 square. A square minus b square formula, a plus b, a minus b divided by x minus 1. X minus 1, x minus 1 cancel. Now apply the value 1. In place of x apply value 1. 1 plus 1, 2. Okay, I have got a value as 2. Here minus 2. Both are not equal. Therefore, what you want to do? You need to write f dash of 1 minus is not equal to f dash of 1 plus. Therefore, f dash of 1 does not exist. So see this sum, third subdivision. F of x is equal to modulus of x plus modulus of x minus 1. They are given two values at x is equal to 0 and x is equal to 1. They are given two values at x is 0 and x is equal to 1. First I will find for differentiable x is equal to 0. So for x is equal to 0, apply properly. This is going to be 0, 0 minus 0 plus. Going to be 0 means minus 0.1. It's going to be 0 means plus 0.1. That's all. I have taken the values for x. This is x value. X is equal to, this x value is equal to x. Now first I need to find for x is equal to 0. No, first write the formula. What is the formula we need to write? F dash of 0 minus limit x tends to 0 minus f of x minus f of 0 divided by x minus 0. The same another formula for right hand. F dash of 0 plus limit x tends to 0 plus f of x minus f of 0 divided by x minus 0. Now we can start to write modulus given. So only I written this number line such a. So first write limit x tends to 0 minus. First take minus 0.1 value here. If we are going to take a minus 0.1, x is equal to minus 0. Which shows negative. So put minus x. After that take minus 0.1. Minus 0.1 minus 1. This is also negative. You can able to understand what I am saying, I think so. Both are going to be a negative values only. So this is going to be minus. Open the bracket x minus 1. Listen very carefully. 0 before left value is nothing but minus 0.1. If I am going to apply minus 0.1, we get negative value only. Minus 0.1 minus 1 negative value only. So minus x minus 1. So leave it as it is. Minus of f of 0. 0, 0 minus 1. I am getting the answers. Listen carefully. Open the bracket. This is 0. Plus apply 0. 0 minus 1. 0 minus 1 is minus 1. I got a value as minus 1. So write minus 1. I erase and put minus 1. Divide by x minus 0 is x. So limit x tends to 0 minus. Listen carefully. This is minus x minus into minus plus 1 minus into minus plus 1 divided by x. Divided by x. I have done small mistake, students. This is not f of 0. This 0 should be applied this f of x. Here f of x is value is this one, not this one value. Here f of x value is this one. So apply here only. If I going to apply here 0, this is becomes minus 0, we don't need to apply. This becomes minus, so put minus here also. This minus is minus here, this is minus 0, we don't need to apply, put minus. 0 minus 1, 0 minus 1 is minus 1, minus into minus plus, plus into minus is here minus. So this plus minus, minus will be cancelled. So limit x tends to 0 minus, minus 2x by x, both will be cancelled. Remaining is minus 2, we don't need to apply, so put minus 2 as it is. The same apply here also, limit x tends to 0 plus. I need to apply x value is nothing but 0.1, apply 0.1. If I going to apply 0.1, this is positive, leave it as is positive. If I going to apply 0.1, listen very carefully, we are going to apply 0.1, 0.1 minus 1, which becomes a negative value only. Listen carefully, apply going to 0.1, 0.1 minus 1, which gives only negative value. So minus of x minus 1 only. Sir, if I am going to apply x value is nothing but 2. After 0, I can 2, no sir, 2. 2 minus 1 is 1. Positive value, sir, we can apply positive value. No. I told to take only the nearest value only. Nearest value, take the nearest value. Nearest value is 0.1. 0.1 minus 1 is negative value. So minus of x minus 1. Minus f of 0. This 0 you should not apply here. This is f of, apply here. Apply here means nothing but open the bracket 0. You need to put 0. Leave it as it is. Minus 0 minus 1. 0 minus 1 is minus 1 divided by close the bracket. X minus 0 is x. X minus 0 is nothing but x. So what is going to answer is going to be limit x tends to 0 plus x minus x minus into minus plus 1. Next minus into minus plus nothing but minus 1 divide by x. Limit x tends to 0 plus x minus x plus 1 minus answer is nothing but 0 by x. Therefore limit x tends to 0 plus 0 by x is nothing but 0. There is no x value also you can able to apply. So limit straight answer write the straight answer as 0. Therefore f dash of 0 minus is not equal to f dash of 0 plus. Therefore f dash of 0 does not exist. This for x is equal to 0. For x equal to 1 I need to apply. This is x is equal to 1. This is minus 1. This is 1 plus. 1 minus and 1 plus. If I can apply x is equal to 0.9. For this x is equal to 1.1. Okay. Apply. First write the formula. Separate and write the formula. F dash of 1 minus limit x tends to 1 minus f of x minus f of 0 divide by x minus 0. F dash of 1 plus limit x tends to 1 plus f of x minus f of 0, sorry, this is not 0, this is 1 no. At x is equal to 1 only we are going to find. So I need to put 1 here also, x minus 1, here also 1. It should not come 0, 1. So first apply the limit x tends to 1 minus. First if I am going to take value of 0.9, apply here 0.9 is a positive value. So write as it is x 0.9. 0.9 minus 1 which gives a negative value minus of x minus 1. Listen carefully. X is equal to 1 means I need to apply the nearest value in the left hand side 0.9. 0.9 is a positive value. So positive x. 0.9 minus 1. 0.9 minus 1 which gives a negative 0.9 minus 1 which gives a negative value. So minus of x minus 1 minus open the bracket. This one you should apply here only. 1 minus open the bracket. 1 minus 1 0 close the bracket divided by x minus 1. So limit x tends to 1 minus x minus x minus into minus plus 1. This is minus 1 divide by x minus 1. X minus a both will be cancelled. Tends to 1 minus 0 by x minus 1. So limit you should not put 1 minus 1 0 0 by 0 undefined form. You should not apply like that. First wait. X tends to 1 minus 0 by anything is nothing but 0. After that you can put 0 straightly. So this one is over. Next I need to take a positive limit. Limit x tends to 1 plus. So take the value is 1.1. 1.1 is nothing but positive value. Write positive x as it is. 1.1. 1.1 minus 1 which is a positive value. Take write positive values plus x minus 1. Positive value no. Minus. This f of 1 apply here only. Open the bracket 1 plus 1 minus 1 is nothing but 0 divide by x minus 1 is equal to limit x tends to 1 plus x plus x minus 1. This is also minus 1 divide by x minus 1. So limit x tends to 1 plus x 2x minus 1 minus 2 divide by x minus 1. Limit x tends to 1 plus 2 is common, take it outside, x minus 1 divided by x minus 1, both will be cancelled. There is only one constant, so write as it is 2. So both are not equal here also. So I can write f dash of 1 minus is not equal to f dash of 1 plus, therefore f dash of 1 does not exist. So last sum in the third sum, last subdivision in the third sum. So what I can do, f of x is equal to sin x, sin modulus of x, not sin x, sin modulus of x at x is equal to 0. For this you need to learn one important formula. What is the formula? Limit x tends to 0, sin x divided by x is equal to 1. If there is x, otherwise the formula we can write in another way also. Limit theta tends to 0, sin theta divided by theta is equal to 1. This formula you need to learn very carefully. Then you know another formula. Sin of minus theta is nothing but minus sin theta. Sin of minus theta is nothing but minus sin theta. If I am going to put negative value, the answer is negative only. The same, sin of theta is not going to be a sin theta. If it is going to be a positive value, answer is positive only. If theta is negative, answer is negative. If theta is positive, answer is positive. If x is going to be negative, answer is minus. If x is going to be positive, answer is plus. So if I am going to take the x is nothing but x is equal to 0 means here 0 minus, here 0 plus. What is the value I can put? I can put minus of 0.1, here plus 0.1. This is x value, this is x value. So first right hand limit and left hand limit. First f dash of 0 minus, limit x tends to 0 minus f of x minus f of 0 divided by x minus 0, f dash of 0 plus, limit x tends to 0 plus f of x minus f of 0 divided by x minus 0. So limit the x tends to 0 minus f of x, left hand minus 0.1, sin of minus 0.1 which gives minus only answer. Sin of minus is minus sign, so answer is going to be negative only. So what I can put? Minus sin x. I can need to write as minus sin x minus f of 0. So sin 0 is nothing but 0 divided by x minus 0 is x. So limit x tends to 0 minus minus of sin x divided by x. Let this minus move outside. Minus of limit x is 0 minus sin x divided by x. We have studied one formula. Limit x is 0, x tends to 0, sin x by x is nothing but 1. Sir, here minus, sir, I have told. Even though this is 0 minus or 0 plus, I am going to value, the value I am going to apply is nothing but 0 only. So sin x by x, x and 0 is nothing but 1. What 1? Here minus present, so minus 1. We have got answer is nothing but minus 1. Same I will do for right hand also. Limit x tends to 0 plus, apply 0.1, sin of 0.1, positive value gives positive only, positive value gives only positive only. So write sin x as it is, sin x minus f of 0, sin 0 is 0 divided by x minus 0 is x. So limit x tends to 0 plus sin x by x. You know sin x by x is nothing but 1. So f dash of 0 minus is not equal to f dash of 0 plus. Therefore f dash of 0 does not exist.